Welcome, everyone, to Tech in 20. My name is Clayton Johnson, and I'm happy to have you here. We're looking forward to today's session about Data Center 101. Today we have Morgan Langley with us, who's going to help us understand what's really going on with all of the stuff inside the data center. I know oftentimes, if we ever go into a data center, we end up only looking at the computing stuff, but there's a lot of other things there too. And so as you can see, and as many of you have done, we have a live poll today, and we're going to be doing them throughout the session. You can answer them on text at 22333 in the United States, or using any browser at pollev.com/tech20. So we'll turn the time over now to Morgan. Go for it, and we'll look forward to learning what we can.
All right, thanks, Clayton. Good afternoon, everybody. So what we're going to talk about today is the other things other than, as Clayton indicated, that's not the computing devices in the data center, what goes on around it. And I left this slide up for the moment just to look at, who's been in the CA data center and who's been in other data centers. Obviously, more people are going to have been to other places, but if you get a chance and you're back in Atlanta, trying to arrange a walkthrough of our data center, it's actually pretty interesting. The way they have it laid out, it's world-class, and it's definitely worth an hour or so tour to kind of go underneath the Atlanta office and see what's down there, see who lives down there, because they don't have trolls down there. They actually have a very nice facility, and it's all very interesting. So let's go on to the next slide here and talk a little bit about. There we go. Why do companies have data centers? First and foremost is reliability. Being able to put all of your compute devices in one central location is obviously has advantages. Two is security, hard key security, physical security, being able to ensure that people just can't walk off with IP from your company, et cetera, and obviously efficiency. Because if you can rack them and stack them and cool them and do all that stuff, it's going to make it more efficient. But one thing I wanted to back up here is with reliability is there's a couple things around power. And we all think of reliability as far as network security, all those kinds of things from a CA perspective. But when you look at it from a DCIM or data center, people that work in data centers, whether that application is reliable or not, they don't care. What they do care about is whether the power and cooling is reliable to keep it running every day. So they have some terms. One is called N+1, which N is being the resources you have, in this case power, and you have +1, which means you have some extra. There's 2N, which means I've got the power that's required, and I double it. So keeping it in simple terms, N+1 is if I have 10 kids over for a birthday party, I'm going to make 12 cupcakes so that they all have them, just in case one other one shows up or for whatever reason I have a couple extras. 2N means that I would have 20 cupcakes for 10 kids, just in case a lot more showed up or there was a problem. And obviously 2N+1 means double it plus more. We generally see N+1 as the norm. 2N usually in financial institutions. I've never seen 2N+1 in all of the time I've been wandering around data centers with this company. So I think those are probably what you're going to see most frequently. And if you have that in your vocabulary, saying are you N+1 or 2N, they'll know what you're talking about, and you'll have a good conversation. Let me back up here. This wasn't supposed to bill out. So anyways, couple of things in the data center. There are 4 tiers of data centers. One of them is, so tier 1, as you can see down here also, it goes around whether they're non-redundant systems, they don't have a lot of capacity, they have expected availability of 99.671%, which is not 6 sigma, which being 99.999%. But tier 1s will allow 28 hours a year of downtime, getting clear into a tier 4, which allows 0.04, which is somewhere in the neighborhood of about 8 minutes of downtime per year. So within those, there is amounts of redundancy, multiple tiers of equipment that give them backup for power and all that kind of stuff. I don't think I've ever been into a tier 4 yet. I've not seen one. Tier 1, Tier 2s, and Tier 3s are probably fairly common. Get into the bigger companies that need this kind of compute power. They'll have Tier 2 and Tier 3. Tier 4 might be a financial institution, but most likely something even needing more reliability than that. But you generally won't see too many Tier 4 data centers out there. So one thing is when you go into a data center, and you've all heard kilowatt hours. When you look at your electric bill from for your house or apartment every month, it says kilowatt hours. If you walk into a data center and you ask them what are you rated at, how many kilowatt hours are you rated for, they'll laugh at you and know that you have no idea what you're talking about. Energy is what you use because that's a time component. So an electric bulb, 100 watt that runs for 10 hours uses 1 kilowatt hour. So that's energy that's being used. So it's a time component, and that's how it gets its measurement. Power, and in the definition of power is the ability to do work in physics. So power is now measured by kilowatt or megawatt, depending on the size of the capability of the data center in this case. So they're usually in megawatts. So when you come in and you say, what is your data center rated at, they'll say, well, we've got a 1.5 megawatt capability here. And so that's the difference. So I know it doesn't sound like a lot, but when you're trying to have a credible conversation in a data center, it is important to understand the nomenclature and what or how they speak about power there. And so this is one of the things that we learned really pretty early on when I started with this business unit almost 4 years ago, with some of these differences and having that credit and being able to be credible. Let's talk about what's in the data center. Notice that none of my things I'm pointing to here are pointing at racks and computers or storage arrays or anything like that. We're strictly talking about the infrastructure around it. And since all of you have been in data centers before, you walk in there and you see all the racks with computers, and you'll walk over to one, you'll pull out the keyboard, and you'll pull up the screen, and you may start working at that machine. But you walk past a lot of other equipment that also is critical path to ensure that the data center works. There's the HVAC, fire safety equipment in there. They may have a room over where it says here where they have startups and system build-out rooms. They'll have power distribution. We're going to talk about that in some more detail during the call here in the next few slides. Being able to manage and monitor the power. Doing some building automation. Most all of these have some kind of building management system or BMS. You'll hear Siemens, Johnson Controls, things like that, where they have comfort controls and ways to automatically control the data center. You also have standby power, being able to have racks of batteries to be able to power the data center for a short period of time if something bad was to happen. And then obviously security, monitoring and controlling who goes in. There's camera systems in there to see, a lot of times they have what's called a lights out data center, which means there's nobody manning it. And if something happens, they simply go look in the cameras and see what's going on. And then if somebody needs to come in, either they've got a contractor, if it's far enough away, they can walk in the door, or if it's local, they'll send somebody out to go see what's going on in the data center, unless obviously there's somebody there working, putting in some more machines. So this kind of gives you a kind of an idea of how it's really the perimeter devices and what they are within the data center. So let's look a little bit of a schematic and talk about, before I start that, there's another poll here. You have your polling numbers. I'm just interested to understand if take a shot at what uses more power. Is it the compute devices, all that stuff in the middle, or is it the non-computing, heating and air conditioning and all of the other stuff? So take a shot at that. Tell me what you think. So anyways, power comes into the data center. It says utility power, aka transformers. And if any of you have been to the Islandia office, you go out to I believe it's the west side of the building, you'll see 6 of them sitting out there on pads. They're transformers, which means they pulled it off the utility and they are setting it. They're doing some step down voltage, and that comes into a thing called switchgear. And the switchgear is connected to that and the generator. So anytime you literally switch over, so if utility power goes down or something happens, the generator comes on, that switchgear is going to go ahead and say and define where the power's, where it's drawing its power from. That then flows into the UPS and also other things like chillers, cooling towers, pumps, etc. The UPS is the uninterruptible power supply. Does a couple of different things. The first thing it has, it's got batteries, so it's going to supply power if something bad happens for a period of time. You can run on the batteries. The other thing it does, it conditions the power, which means power has fluctuations in it constantly, and all of the computing equipment may be sensitive to that. So it will condition the power. It may also do some step down, but it also, whenever that switchgear happens, there is a spike or a lack there, where the power is gone for a split second. If you didn't have something standing between that and your compute environment, the machines would switch off for a split second, and then everything would reboot. So your whole data center would reset itself. So you need a way to be able to switch over and not have the data center, the compute equipment, notice what happened. So that's what the UPS is going to do for you. And then it also allows you to distribute, because you may have multiple UPSs sitting out in the data center, and they're going to go to, in this case, going to go to power distribution units, PDUs. And then PDUs may do step down from 4.8 volt down to 200 volt, and then it may step down even further than that when it goes down to remote power panels and down to power strips in the server racks themselves. So there may be a power chain of 5 or 6 step downs where you're going not only doing power conversions, but you're also going to multiple breakers. Like a power panel may have 48 breakers. So now I can send those breakers down to different power panels or power strips on the rack, and then the rack will have a set of A and B side power there that you can then plug your computing equipment in. So it kind of gives you an idea of how the data center kind of sees power from the street into the actual compute environment itself. And also in here, there's other things that are shown in red here, UPSs and other types of equipment that are not as sensitive to power interruptions. So they may or may not be inside of that UPS equipment. So that's kind of how the data center sees power and how it uses it. So I see we've got some input here, people that have answered the question. So let's go to the next slide and take a look at how we use power. Well, right in the middle gives you the answer. Only 30% of your total environment is IT equipment, and it may be a little more than that depending on it. And you'll hear some industry numbers called PUE, power usage effectiveness, and data center infrastructure efficiency, DCIE. PUE is that efficiency number, which means that you're getting your compute power and your infrastructure power are getting, the lower the number, so like 1.08 is a very good PUE. So that means that you're not spending that much more on your non-computing equipment as you are your computing equipment. And so the data centers will strive to get that number as low as they can. By the way, when we started CA, their number was well over 2 with their PUE. Now, I think it's somewhere down around 1.6, which is pretty good.
Morgan, does that mean that they were using twice as much power for the non-compute as they were for the compute? Is that what that means? When it was 2?
Yeah, it's probably pretty close, because if you look at this, if you took this as a PUE, this number, and you look at 30%, that's actually would be a PUE of well over 2, if you just did the math on what that 30% equates to. So the idea is, in the data center, if you're going to make it more efficient and start driving that number down, you're going to start looking at chillers, humidifiers, and cracking it. So your air conditioning capabilities, your heat removal capabilities is really where you spend most of your money. So getting those more efficient, that's why you start seeing more and more data centers in places like in Colorado Springs. I've been in 3 of them there in the last month and a half. That's why Facebook's got stuff up in Prineville because they've got free cooling days, and they're also using Columbia River water to help cool their data centers. So they're going for those kinds of efficiencies where they can. And then down at the bottom, you'll see the PDUs and UPSs and switchgears all have an amount of energy they use, but a lot of it also accounts for loss. Anytime, and it's physics, anytime you do a step down in power, there's a loss. So the idea is to minimize that loss as much as you can, and there's ways that can be done. But we had a customer where they actually were running somewhere in the neighborhood of almost 50% loss in their transfer, then realized they had a bad transformer. And what it came down to is, I think we figured it was $390 a day that they were losing just in power loss alone. So all of it adds up, no matter what you're doing. But realistically, the compute equipment is generally pretty standard at between 30 and 35% is normal. So keeping all that in mind, you see in this graph, it shows electrical in and heat out. That's what heat, whenever you use electricity, what's it create? It creates heat. And so the idea in the data center is to extract that heat out as best you can. So in the data center, they don't cool the data center, they extract the heat. And that, technically is how they do it, or what they're looking to do. So how do they do that? There's typical types of cooling that goes on, and there are other kinds, and we'll talk a little bit about that. But the other thing called a computer room air conditioner, or a cracked unit. Big alabaster box. Usually sits on, around the peripheral of the data center. And then you'll have chillers and computer room air handlers, or CRAWs. And so the chiller will sit on the roof out back behind the data center, and it will simply push that cold air into the air handler, and the air handler will send it out. Whereas a CRAC is a self-contained unit that is basically an air conditioner itself. And they'll either sit in the room or on the periphery, or I've seen some where they put them outside the room, and it just blows the air in. So those are the two different kinds that are most common. I've seen some, Facebook, for example, uses what they call a fan wall, which means they use river water, they blow it up into a wall and then pass air through it. So it's like an enormous swamp cooler, and that's how they get a lot of their cooling efficiency. It's used a lot less energy, and it's very efficient. So that's what they've been able to design, but they also move their equipment up there to do that. So within the data center, there are a couple different cooling methods. One of them is simply to push air up through perforated tiles underneath the floor. It comes up in front of the racks, goes through the racks, and goes out through the back and back into the air handlers and out into the atmosphere. That's pretty normal. Some customers use cold out containment. They'll have plenums that are above the racks, or they'll put skirts around the racks. So they'll put both the back. They'll face two rows outboard, and so inboard is hot out containment, and so then they'll just capture it all and send it out that way, or they'll face the ones inboard and they'll have cold out containment. So it depends on how you orient your racks. I've even been into a data center where they had the hot aisle where they had the hot side of one set of racks facing the cold side of the other rack, and it was just terribly inefficient, but that's the way they had it at that point in time. And then obviously, through air temperature, you want to monitor, and you can see this one shows cold out containment in the center with the blue, and being able to monitor that within the data center, understand where your heat is and is not. And those maps change throughout the day, because they, as you ramp up different things within the data center, being batch jobs or other usages, you'll see these maps actually morph throughout the day. Okay, and we're about on the minute here, with it 24 minutes after. So that's what I have today. It's kind of a real flyby. If anybody wants this, we have a much more involved deck that talks about this in detail. That's probably an hour-long doc or an hour-long conversation. Happy to share it if anybody wants it. And if you have a need for that, I'm happy to also give that presentation in much more detail. But at this point, Clayton, any questions?
At this time, if you wish to ask a question, please press star then the number 1 on your telephone keypad. Again, to ask a question, press star 1. At this time, we have no questions.
Okay. Clayton, are you still on?
Oh, I was on mute. Sorry.
Okay, having a great conversation with yourself. All right.
Yeah. So one came in on the chat line, and it was, why do we have so many data centers moving to Phoenix and Vegas?
That is a good question. It really comes down to cost of operation. Lots of power available there because quite often the constraint that you have with the data center is actually getting power from the power company. And that's a normal constraint. Well, these places have plenty of power because there's lots of generation that goes on in those areas, and it's cheap. And also salaries are reasonable, building square footage costs are reasonable, and it's seismically stable. A lot of moving out of, say, California because it's not seismically stable. That's why Wyoming, I've seen them there. Denver's getting very popular, the Denver area, because, and even Phoenix and Vegas for those reasons. But, yeah, the cost per kilowatt hour is pretty cheap down there. And so they tended to really migrate to Vegas and that.
Okay. And then these two that just came in on the poll, what kind of education is normal for a data center operator, and what kind of savings are really possible or normal?
Well, that's a good question. I've sat down with folks who design data centers that have PhDs. They're electrical engineers. And when you look at the really big ones, they're generally a lot of times double E's or mechanical engineers. Some of them might have specialty degrees in that stuff. That's probably becoming more prominent, especially with the big data centers. And the other half of the question was, Clayton?
Well, before we go on, one of the guys that was working in Islandia when I went through was a marine engineer.
Oh, yeah, that was
Eric stuff.
Yeah. Eric was doing work in there, and he was actually contracting with us. He owns a company called Marine Engineering, and he actually has a degree in marine engineering, which is kind of unusual. But yeah, they're the systems in there are not wholly different. I mean, mechanical systems are mechanical systems, but the data centers we see now are becoming so sophisticated, and the infrastructure around them that just getting a raised floor and blowing a bunch of cold air into it just isn't feasible anymore. You really have to understand how it's all wired together because they're growing so exponentially every month, and the power demands are getting so great, and so are the cooling demands. And then space is generally not the problem because all the compute equipment is becoming much smaller, and then you're able to condense it with VMs and things like that. So space isn't normally the problem, even within our data center. I don't think we use more than about 50 or 60% of the space. It's the problem of getting enough power in to run it all, but it's getting also the power from the utility, because that's where there's a lot of times constraints. The utility will say, "I'm sorry, there's no more left," and so that drives a lot of it.
So the other question was, what kind of savings are really possible or normal? I mean, when we start being able to be more efficient, are we talking 10%, 20%, 4%? What's a good number?
That's a good question. It really depends on when it was built. You get some of the new state-of-the-art data centers, there isn't a lot more you're going to squeeze out of them because their compute environment's so dense. What I find people doing is they're actually taking them apart and rebuilding entire new ones to get more savings, because the computing equipment is not really, there's a lot of cost there, but that tends to cycle pretty quickly. Once the warranty runs out on a computer, they'll rack and stack a new one every 3 years because, kind of trained that way. But, with all the cracks and craws in UPS, it's a construction project to remove it and replace it, but it's capital equipment. It's $1 million. So that stuff doesn't get moved as often And you'll see some of these 10 years old that are probably 30% less efficient than a new one. And that's pretty significant if you've got 5 or 10 of them sitting out there. That's really where the money savings can be, is in some of that bigger hardware. But quite often, most data centers are not monitored that closely that they can actually tell you that. And that's really where we can at CA is we're actually able to tell them where they're spending their money and how efficient or inefficient they are. So it's getting, the wave has started. You know, the DCIM stuff that we're selling is actually the newest, is, you know, probably the new wave of technology or software products out there right now. But also to give you an idea, though, one thing is, you know, Facebook's Prineville data center uses 30 megawatts. The city of Prineville only uses 28 megawatts. One data center runs more than the entire city.
Wow. So last question on this was, you know, the one about the solutions that you can read there. Maybe you can answer that real quick for us.
I'm sorry, could you repeat that for me, Clayton?
Well, on the slide it says our CA solutions integrated that service assurance or automation can take advantage of the information that we have, so that we get from the data center.
Oh, sure. Well, you know, we built our basic monitoring is built on eHealth, and we're switching that over to IM2.0. So, you know, there's kind of the start of it. So those of you who have ever seen eHealth or worked on it, you know, it's a monitor of monitors. We're able to use that database and everything, or use that product to talk to competitive products and our own. So we kind of do the same thing here, is we're talking to a bunch of competitive software as well as non-native equipment and bringing all that information into one place, and then taking all that. So, you know, we can also talk with Spectrum clients, and then taking that information and visualizing using all the different alerts and things like that. So it's already been plugged into service automation products since the day we started, but now we've taken it to the next level of having the 3D modeling and all of that. So we've been at this, we've had that product available for almost 4 years now.
Wow. So why don't you move on to the next one? Ryan, do we have any questions on the line at all?
We have no questions.
Okay, so Morgan, if you'll take just a minute and summarize, then hand it back to me.
Okay, good enough. So what we covered during this half hour was really the environment of power and cooling, which is a part of what the data center is concerned about. And those are probably the ones that are affected by the amount of computing equipment, whereas space is kind of what it is. And so what we looked at power chain, we looked at, you know, some power definitions, reliability, and then looked at the different cooling methodologies that are available in most data centers today. Like I said, there are some more that are more state-of-the-art than these, but if you walk into 99% of them, they'll look like that.
Good. Thanks so much. We appreciate it. I mean, there's a lot to learn, and it really is helpful to go through this and learn it and to see it, to understand the terminologies and the issues that people are struggling with inside the data centers. And, you know, every one of our customers has one. And whether they're, you know, whether it's their own data center or they're paying somebody else to run the data center or they're paying a cloud, there's still a data center out there somewhere that they're having to deal with, at least somewhat, if not just paying for it. But we appreciate it, and lots of good information. So next week, we'll look at device DNA and the way that we can tell what kind of devices are coming into our networks and what we can do with that information once we find out. And so we'll look forward to talking with you next week. And until then, good selling.